In this video, we just want to remind you, or I just want to remind you of some motion examples that may be on the AP exam. When is an ant's acceleration? So we have the velocity graph. When is the acceleration 0? Well, just remember that the derivative of velocity is acceleration. So what we're really saying is when is the derivative graph of the graph we've been given, when is its derivative 0? Well, 1 and 3 are the times when that occurs. When is the ant moving to the right or forward? Well, that occurs, of course, when the velocity is positive. So that's from 2 to 4. When is the speed at the greatest? Well, remember, speed is the absolute value of velocity. So you look here and you say, well, here the velocity is -4, here the velocity is 2, but since speed is the absolute value, the speed here is 4, so at time 1 we hit our maximum speed, and it's 4. Now, speeding up using a graph, I think the easiest way to do speeding up is to talk about the fact that whenever the velocity is moving away from 0, the ant is speeding up. When the velocity is moving towards 0, you're slowing down. And I hope that makes sense, that if your velocity is going closer and closer to 0, you're slowing down. And if your velocity is going further and further away, you're speeding up. There is another way to justify that that's easier with an equation, and that's that speeding up is where velocity and acceleration have the same sign. I think it's easier with a graph. I think it's easier with a graph to do the, it's moving away from 0, but I just want you to see that, here the velocity is negative and so is the acceleration. Here the velocity is positive and so is the acceleration. Remember, acceleration is just the derivative. So, really, the reason is velocity is positive and increasing, negative and decreasing. Okay? If you had an equation for velocity, and you could use your calculator or just use end deriv, checking the signs is easier than graphing it, but either way will work. When is the ant furthest away from its starting point? Well, this really has to do, of course, with integrals, and the idea here that we've got a lot of negative area. That means the ant's walking backwards and doing a lot of it, then it begins to walk forward again. So if you think about this ant as a starting spot, let me maybe just do it right here. As a starting spot, it walks backwards, backwards, and backwards. The area tells us how far. Okay, if we could find the area, that would tell us how far it moved backwards. So then at time 2, it changes direction and begins to walk back. So it's at time 2 that the ant is furthest away from its starting point, because then it begins to walk back towards its starting point.